Hi, I'm Christine Franks from the Software Engineering Group at UC Davis, and in this video I will be demonstrating the features and robustness of CACHECA, a plugin for the Eclipse integrated development environment that utilizes a cache-based model to generate code suggestions. Code suggestions are tokens provided to a programmer during code editing that the programmer might be intending to write next, and the predictions can, when correct, increase a programmer's productivity. In Eclipse, this functionality is termed Content Assist. CACHECA's cache model exploits the modular structure of code and often suggests tokens based on the local vocabulary and usage patterns specific to a particular file. CACHECA combines the traditional n-gram approach with this new cache model based on localness, then combines the suggestions with the default syntactic and semantic suggestions provided by Eclipse in order to produce an optimal list that is twice as good as Eclipse alone, as demonstrated by our extensive testing on open source projects. The cornerstone of CACHECA is the mix model. In the mix model, we first assemble the default suggestion list from Eclipse and the n-gram and cache-based list we generate. If there is overlap of suggestions within the top three of both lists, then we place those suggestions at the top of the new list, using the JavaDoc and parameter data provided by Eclipse. Next, if there are less than 3 suggestions in either list, we add the top suggestion from those lists. Finally, any remaining suggestions are interleaved to form the final suggestion list. Let's take a look at an example. This is the Java editor of Eclipse, with the default Content Assist enabled. Math is a library with a lot of commonly used methods. When I begin math dot, Eclipse presents a laundry list of the possible methods. However, notice that I've used math.min earlier. Let's switch to CACHECA by going to Window, Preferences, then searching for Content Assist. We need to enable the CACHECA sorting algorithm, and then select CACHECA. Now let's see what CACHECA suggests. Math.min is placed second on the list. This is a substantial improvement upon the default list because CACHECA could identify the local context and provide relevant suggestions. Here's another example. Here we have a context variable called CTX. When we invoke CACHECA, we can see that the top 3 methods are very relevant. In fact, we've used all 3 in other parts of this file. GetDocument is used directly above it. GetInvocationOffset is used at the top. And GetCompilation is used later in the file. For comparison, let's switch back to the default suggestion list, reversing the change we made earlier by again going to Window Preferences and deselecting CACHECA, then enabling the relevant sorting. Although all 3 suggestions appear, they are ranked low compared to the CACHECA sorting algorithm's weighting. CACHECA emphasizes the localness of the suggestions. Again, my name is Christine Franks from UC Davis. Thank you for watching this demo of CACHECA. This work was supported by a grant from the National Science Foundation.